The BIG IP LTM platform is a network appliance that manages and balances traffic for network equipment such as web servers, cache servers, routers, firewalls, and proxy servers. A variety of the LTM system's useful features meet the special needs of e-commerce sites, internet providers, and managers of large intranets. During this lesson, you will learn the purpose and function of the configuration, licensing, and setup utilities. At the end of this lesson, you will have a licensed BIG IP system and secure access to both the command line interface and the web-based configuration utility. There are 4 initial steps to setting up the BIG IP system. Set up IP address of the management port via the config utility or LCD panel controls. License the system through the web interface. Run the setup utility, which configures management access, admin passwords, provisioning the system, and network and VLAN definitions. A typical F5 device will have a management port, USB port, failover port, console ports, Ethernet ports, LCD panel, and controls. The management IP address doesn't have to be changed, but since all systems have the same IP address, it is best to change the IP to one that makes sense for your network. Our lab will be using 192.168.4.31. The management port's IP, mask, and gateway are typically set prior to licensing the system. This can be done with the config tool, type config at the CLI, or via the LCD panel. Note, if using the LCD panel, you must choose to commit the settings before they are set. Licensing, provisioning, and redundancy wizards make the initial configuration a breeze. Production systems ship with a pre-installed key. The training lab does not have a pre-installed key on the system, so you will need to obtain a valid key. Production licenses do not expire, but they do preclude an upgrade at a later time. The manual method creates dossier.do and license.txt files. When installing onto the BIG IP, the license file must be config/bigip.license. When using the GUI to import a license, regardless of the name of the license, it will be converted to bigip.license on the BIG IP system. Provisioning gives you some control over the resources, both CPU and RAM, which are allocated to each licensed module. Depending on your available resources, you may have to reduce the allocation resources of a GTM to its minimum while allocating more resources to the LTM. The purpose of the setup utility is to configure administrative access to the BIG IP LTM. It includes setup of 2 user ID password combinations, 1 command line, and 1 web interface, and IP address and access types for the self IPs. This page establishes passwords and accessibility. The standard network configuration option can create internal, external, and HA VLANs, their self IPs, and the ports for the VLANs. The advanced network configuration ends the setup utility. The user must then manually create VLANs, self IPs, partner addresses, etc. The screenshot is of a basic config and shows fields that only appear if the system is set to be part of a redundant pair. The advanced network configuration ends the setup utility. The user must then manually create VLANs, self IPs, partner addresses, etc. Provisioned modules will show up at the left-hand side of the screen. The screenshot shows a system minimally licensed for LTM. Other modules may be licensed, but not provisioned. If you have difficulty connecting to the web interface, you must ensure that port 443 is open on the VLAN to which VLAN you are attaching. The basic config opens port 443 only on the external VLAN self IPs, while the internal default to default. A list of ports in /config/bigip_base.conf. Serial port settings default to 19200 N81, but can be changed via the LCD panel or the SCCP menu. UCS files contain all configuration information for that system. Normally, they are only restored to the same system. In the case of an RMA, the UCS file can be used as the basis for configuring the replacement system quickly. AOM is the always-on management and is a second OS to TMOS for the new platforms of 1600s, 3600s, 6900s. SCCP stands for Switch Card Control Processor and is a second OS to TMOS for older platforms such as the 1500s, 3400s, and 6400s. The CPU is covered by a shroud for airflow. F5 has specifically designed not only the software, but also the hardware as a full proxy networking device. This board is both a CPU motherboard, an integrated switch card, and hosts a second operating system called SCCP or AOM. A fully loaded Viprion 2400 system contains 4 2100 blades, with each blade composed of a single quad-core processor, 16 gigs of RAM, and 8 10 gigabit fiber ports. A fully loaded Viprion 4400 system contains 4 4200 blades, with each blade composed of 2 quad-core processors, 16 gigs of RAM. A fully loaded Viprion 4400 system contains 4 4200 blades, with each blade composed of 2 quad-core processors, 16 gigs of RAM, 4 gigabit copper ports, and 8 10 gigabit fiber ports. F5 devices have a variety of add-on hardware, such as redundant power supplies, extra RAM, and accelerator cards. This shows which versions of software each device can support. SCCP and AOM should be given an address as part of installation. Subsequently, admins can attach to the box from a remote location even when TMOS is rebooting. Older systems, 1500s, etc., have SCCP. Newer systems, 1600s, etc., have AOM. Regardless, network settings can only be set when connected via serial console. If you ever need F5 support, have the serial number and product model of the device handy. You can search tech.f5.com for solutions to your problems. F5's solution articles will contain a problem description and a solution on how to fix the problem. When troubleshooting your F5 device, TCP dumps can be a powerful tool to determine connections and routing problems. Similar tools include Snoop, Wireshark, EtherPeek, and of course, sniffers. If you are connected with a terminal or a terminal emulator software, you should set term type to VT100. Setting the gateway value is arbitrary and optional. It is done only to determine how and to verify that the net mask was set to 255.255.0.0. The config tool can be accessed via SSH to the default 192.168.1.245 address. If this method were used, access would be disrupted when the IP address was changed. A valid license is required before proceeding to the next lab. For this lab, we're going to do our basic setup. We're going to assign our management IP. We're going to do our provisioning. We're going to set our passwords. We're going to set our internal VLAN, our external VLAN. Our HA VLAN will be set later in this course. We will set our backup and our access. And then we will create a base config backup.